Hey everyone, it's Justin again. This lesson is all about the volume of spheres. We're going to build on your knowledge from the previous lesson to come up with the formula for this. My friend Marie was at it again. She made another simulation for you to check out. It's a short activity that comes right before your notes template for this lesson. So pause the video now so that you can go through it. By the end of this lesson, you will be able to calculate the volume of spheres and hemispheres. First, we'll compare the volume of spheres to the volume of cones in order to develop a formula. Then, we'll use that formula to complete an example problem. After, we'll learn how to calculate the volume of hemispheres and then complete one more example problem. Let's compare spheres to cones and see where this can take us. We're going to think back to the previous lesson. In that lesson, we worked with cones and used this formula to calculate their volume. Remember that capital V represents the cone's volume, capital B represents the area of the base, and capital H represents the distance between the base and the apex, or the opposite vertex. We learned that in the previous lesson, but how does that relate to the volume of a sphere? Well, here's a sphere, and a circle going through the middle of the sphere happens to match the area of the base of this cone. The circle that represents big B, the base of the cone, can also be found as part of the sphere, although it's not technically a base when it's inside of a sphere. The height of the cone also matches the distance from one end of the sphere to the other. We don't technically say that spheres have a height, but this would be equal to 2 times its radius, and it does match the height of the cone. Since the values of big B and big H can be found on both of these figures, do you think they have the same volume as each other? What did my friend Marie's simulation show you about spheres and cones? It took the volume of 2 cones to fill up the sphere. She used sand in her simulation, but water or something similar would help us to visualize this too. So, if this is the formula for the volume of a cone, how can we change it to adapt it to a sphere? We would multiply the whole thing by 2. And since 2 times 1/3 is 2/3, we can simplify a bit. Awesome, this looks great so far, but we should probably look at this a little closer because you can't have a formula for the volume of a sphere that involves parts that a sphere doesn't have, like a base and a height. Earlier when we were comparing the sphere to the cone, we were saying that the area of a circle going through the center of the sphere matched the base of the cone. Okay, I really don't want to keep calling this big B because it's not a base here. But how could I correctly represent it? It would be the area of a circle with R being the radius of the sphere. So let's substitute that in for big B. Next, let's figure out what to replace big H with. Let's think back to how we related it to a cone. We said that the height of the cone matched the distance from one end of the sphere to the other. Can you think of a vocabulary term related to circles that we could use to describe this length on a sphere? This is the same thing as the diameter, or 2 radii. So, what can we replace capital H with? We can replace capital H with 2r. Okay, so this looks pretty good to me. Do you see how we can simplify this formula, though? Can you use your algebra background to simplify this? Remember, this whole thing is multiplication. It can be rewritten like this, if that'll help you to simplify it. Pause the video here and try to simplify this expression now. 2 times 2/3 is 4/3. Pi can be brought down. And r squared times r is r cubed. Whew, nice work. We now have the formula for the volume of a sphere. And even better, the only value we need to substitute in to calculate its volume is the sphere's radius. Let's try this example problem now. It says, calculate the volume of a sphere with a diameter of 10 units, and round to the 10th place. Go ahead and give this one a try on your own. Pause the video here. Did you remember to use the formula we came up with? We need to substitute the radius in here for r. What's the radius if the diameter is 10 units? The radius is half of the diameter. In this case, that means it's 5 units. Let's substitute that into the equation for r. Okay, now what should we do? Let's type this into a calculator, starting with 4/3 times pi times 5 cubed. Go ahead and do this on your own, then round to the nearest 10th place. Pause the video so you can try calculating it. You should have 523.6 when rounding to the 10th place. And what about our units? They are going to be cubed. Great job so far. Now, what about hemispheres? How do hemispheres relate to spheres? Here's a sphere again, and if we take away half of it, we are left with a hemisphere. We can remember that a hemisphere is half of a sphere because hemi means half. Using the volume of a sphere, how can we calculate the volume of a hemisphere? We can multiply it by 1/2. And to simplify, we're going to multiply the coefficient of 4/3 by 1/2. So what's 4/3 times 1/2? Half of 4/3 is 2/3. So let's replace 4/3 with 2/3 in our formula. This is the formula for the volume of a hemisphere. Here's one more example problem. It says calculate the volume of a hemisphere with a diameter of 8 units, and then round to the 10th place. Pause the video here so that you can work through this on your own. Did you remember to use the hemisphere formula we came up with? We need to substitute the radius in here for r. What is the radius if the diameter is 8 units? The radius is half of 8, which is 4. Let's substitute that into the equation for r. Then we can type this into a calculator starting with 2/3 times pi times 4 cubed. Go ahead and do this now if you haven't already. You should have gotten 134.0 when rounding to the 10th place. And let's not forget our units. Because we're dealing with volume, they are going to be cubed. Now you can calculate the volume of spheres and hemispheres. Remember that the diameter of a circle is twice the radius. And make sure it is the radius that you're substituting into either of these formulas. I want to once again thank my friend Marie for making us another great simulation in your PDF, and encourage you to have some fun trying to make a simulation just like it. Then, of course, remember to complete your practice game. See you next time!
Hey!